Hi there, Terry Panhorst here again. Today I want to share with you about an interesting and economically important mineral, galena. Now to do this, what we're going to do is at first look at some of the characteristics of galena, and then we'll look at some specific locations in Idaho where galena has been found in the past. To begin with, let's talk about the mineralogy of galena. Now, galena is a sulfide mineral. And when I use that term, what I mean is a mineral that's composed of both a metal and sulfur. In this particular case, galena is composed of lead, abbreviated Pb, and sulfur, S. They're in a one-to-one relationship, so the basic formula for galena is Pbs. If you look at the diagram on the left, this is an atomic representation of the structure of galena. And there we can see the red balls, which represent lead atoms, and the yellow balls, which represent sulfur atoms, are stacked in a very orderly fashion, creating this very cubic structure. Now, as the mineral grows and gets larger, it just keeps repeating this cubic structure over and over again. And in the photograph on the right, you can see how in a hand sample of galena, that same cubic form comes through. It's a lot of right angles on the crystal faces, and overall the mineral tends to form a cube. Now there are some other common sulfide minerals. For instance, the iron sulfide pyrite, the copper iron sulfide chalcopyrite, and the zinc sulfide sphalerite. Now, all three of these minerals do occur fairly commonly with galena. Now, before we get more into some of the characteristics of galena, I do want to sidestep here and talk a little bit about the economic importance of this mineral. As an indication of that, in 2019, the U.S. consumed over 3.5 billion pounds of lead, which had a value of somewhere in the order of $630 million. Well, that's a lot of lead. What are we using that much for? Well, it's used mostly in automotive batteries. If you look at a typical battery, as shown in the diagram in the upper right, the internal portion of this battery is occupied by a lot of thin lead plates, which are used to help generate the electrical charge that the battery holds. Each typical automotive battery has about 19 pounds of lead in it, which is why batteries themselves are rather heavy. Now, that same year, 2019, there were over 100 million automotive batteries manufactured in North America. So you can see that's going to require an enormous amount of lead. And automotive batteries make up over 90% of the lead that we mine each year. Now, in addition, galena plays a very important role because it may also host the precious metal silver. The Coeur d'Alene district in northern Idaho is a classic example of a situation where galena hosts silver in high enough grades that it can be profitably mined. And since the 1880s, when the Coeur d'Alene district was discovered, it's produced well over 1 billion ounces. Now you can see it with current day prices of silver at about $15 an ounce. That's a significant amount of money. All right, let's look at some of the physical characteristics of galena. First, it has a very notable metallic luster. Now, when I use the term luster, what I'm talking about is the mineral's appearance when we reflect light off of the surface of the mineral. Here's an example of some galena with fairly fresh surfaces. And as you can see, they look very metallic. It looks like a big lump of metal, except that it again is showing that very cubic form. The fresh surfaces are particularly shiny. They can be almost mirror-like. If the surfaces have been weathered a little bit, they might get looking a little dusty and they won't be quite so reflective. But nonetheless, if you just break off a tiny piece and look at it, you'll see that fresh, very shiny surface again. Another characteristic of galena is that it's very heavy compared to other minerals. In other words, it has a relatively high density. Now, when geologists talk about density, they usually express it as specific gravity. Now, in reality, the number for specific gravity is the same as the number for the density. It's just that specific gravity is calculated in a way so there aren't any units associated with it, just the number. Now, let me show you an example of what I'm talking about here with specific gravity. In this photograph, we have 3 different objects, and all the objects are clearly different sizes, but they all are approximately the same weight, about 4 pounds. On the left, there's a block of galena. In the middle, there's a cobble of granite. And on the right side, there's this large glass vase, which has been filled part of the way with water. 3 different objects, all the same weight. Well, how can they all have the same weight? Well, clearly they must have a big difference in density. If we look at the specific gravity of the 3 different objects, that helps explain that observation. Galena, on the left, has a specific gravity somewhere in the neighborhood of 7 to 7.5. The granite cobble, typical granite, has a specific gravity somewhere at about 2.5. And the glass and water combination together has a specific gravity that I would estimate at about 1.5. Now you might look at the galena and the granite and wonder, well, now wait a minute. They have a very big difference in specific gravity, and yet size-wise they're not that different. How can that be? Well, that is an indication not only of how the elements are stacked in the mineral structure themselves, but also what elements are included. The galena has such a high specific gravity because it has lead. Granite, on the other hand, has much lower weight atoms that compose those minerals and therefore doesn't have nearly as high a specific gravity. Last physical characteristic I'll mention is the fact that galena tends to have 3 directions of what's called perfect cleavage. Now again, time for some definitions. When we talk about cleavage, what we're talking about is a tendency to break in certain directions. And if it's perfect, then what that means is that it's always well developed in the specimens. And galena does show 3 directions of perfect cleavage very reliably. Here's an example of what happens with a piece of galena if you take it and tap it lightly with a hammer. It breaks apart. But when it breaks along those cleavage directions. And all it does is repeat that same sort of cubic form that we saw earlier. The smaller pieces are also resembling cubes, just like some of the larger ones, like the large one on the right. Even the smallest fragments, like those 2 little ones that I've circled in the lower portion of the photograph, they also tend to have that same cubic form to them. So when you look at galena, or if you test galena by breaking it, it will reliably show you the cubic form that we can see here on that sample. Next, I'd like to talk about some of the typical geologic occurrences for galena. First one are what are called vein deposits. And a vein deposit is where we get filling along some form of an open fracture. Typically, the fracture is probably an old fault. Fluids moved up along the fault and deposited minerals as they were migrating up the fault. This is a cross-section of a vein at a tungsten mine in Canada. And the vein itself is that kind of dark ribbon extending from the upper right side of the diagram down toward the lower left. So it's a simple vein because there was only one vein there, and yet it was continuous enough that the tungsten mineralization was mineable. Here's an example of a vein that was exposed in the wall of an open pit. Okay, the vein itself is composed of calcite, which is sort of a really dark brown color, and it's outlined by those yellow arrows that we can see on the diagram. It's also extending from the upper right corner of the photograph toward the left center portion of the photograph. One can also have what are called bedded deposits. And in a bedded deposit there, the mineralization tends to follow the bedding in sedimentary or metamorphic rocks. So almost all sedimentary rocks show some form of bedding. And metamorphic rocks many times will show that same characteristic. Let's look at an example of a bedded Galena deposit. Here you can see those thin little layers that look sort of silvery or metallic stretching from the left side to the right side of the photograph, and there are 3 or 4 of them that are identifiable in this photo. This is galena that's following the bedding of the enclosed host rock. In both of these cases, vein deposits and bedded deposits, the galena very frequently occurs as a massive replacement of the host rock. Here's an example of massive replacement where galena has come in and completely replaced the host rock. Instead of growing some large crystals, nicely cubic in form, instead what has happened is the galena forms a whole multitude of tiny little crystals that grow together and interlock. We can still see the cleavage surfaces on that galena, however, by some of the shiny forms that you can see in this photograph. Now I should point out that even though this sample is only about 6 inches long and 4 inches wide, it still weighs nearly 7 pounds. So that high specific gravity that is so characteristic of galena comes through. In addition, in these types of deposits, you may find what are called vugs. Now, vugs are just openings in the host rock, and the significance of vugs is that there the crystals can grow and show their true form. That's where some of the best mineral specimens come from. Here's an example of a vug in a galena replacement deposit where the vug itself is sort of triangular shape, and within that vug we've now got some very large galena crystals growing. Now, if you were able to pry one of those galena crystals out of there, I was never able to, but if you could, I think what you'd find is that an individual crystal like that can weigh 50 to 100 pounds, so it would be a significant amount of weight. Now let's look at some counties in Idaho where galena is known to occur. We'll go through these counties in alphabetical order, and occasionally I'll show examples of the galena from that particular county by showing you a photograph from the museum collection. I should point out that the source of these counties is an excellent reference by Ream, published in 2004, his second edition of Idaho Minerals. It's an exhaustive study looking at the minerals that occur in Idaho. This book is available online and at the gift shop at the museum. We'll start with Blaine County in south central Idaho. Blaine County was well known in the old days because it hosted the Wood River District, which was a large producer of Galena veins containing silver. In fact, Blaine County also has the distinction of hosting an old mining camp by the name of Galena, shown by that red dot up in the northwest part of the county itself. The town was established in 1879, but was relatively short-lived, like a lot of the old mining camps were. Apparently, it was abandoned by 1890. And its name was derived from the fact that there were a lot of Galena veins in the surrounding mountains. Here's an example of one of those veins from Blaine County. The Galena is that spot in the center of the specimen that looks very metallic, and you can also see other smaller occurrences of it scattered throughout the sample. The white material that appears in the sample is probably quartz. Boise County has hosted some vein Galena itself, and that has been mined for not only silver, but also occasionally some gold has been associated with it. An example of some Boise County Galena material. Here we can see the Galena as those small little gray blebs sort of distributed through the rock, which appears to be a granite host material. Galena was reported at one location in Boundary County on the very northern edge of the state. Custer County in the central portion of the state has various locations where Galena has been found with other minerals. This is an example of some Galena from Custer County, where contained within the Galena appears to be some small little blebs of more of a golden mineral, which is most likely pyrite. Fremont County on the far east side of the state also has reported some Galena occurrences. Gem County on the western side of Idaho also hosts some Galena veins, particularly in the boundary area between Boise County and Gem County. Lemhi County in the east central portion of the state has reported various locations of Galena, with oftentimes occurring with zinc, sphalerite, and copper, chalcopyrite. And locally, there were also lots of enrichment of silver in those Galena veins. Now, Shoshone County in the northern part of the state holds the distinction of having the greatest production of Galena. There, many of the silver mines of the Coeur d'Alene district have Galena as the host material. These mines continue to operate today. This is an example of some of the massive silver-bearing Galena from the Coeur d'Alene district in Shoshone County that's being mined today. The modern mines of the Coeur d'Alene district are very large-scale operations. They employ many hundreds of people and are able to follow these mineralized structures thousands of feet into the ground. And finally, Washington County on the far west side of the state has reported some Galena occurrences. Now you can see this is a fairly full list of counties in Idaho. with reported Galena occurrences. But there are probably Galena occurrences in some of the other counties as well. It's just that they haven't made it into the literature to join this group here. But Galena is a common enough mineral that one could expect to find it in a number of different counties. Now, Galena has been found in a lot of different states throughout the United States. But in Idaho, it has formed a real important backbone of a lot of the mineral production from this state. I would encourage you to visit the Idaho Museum of Mining and Geology to view some of our samples of galena as well as other minerals collected throughout the state. Thank you for joining me today.